Welcome to Beyond the AGM, a brand new project from Agoracom in which we take the time to speak with small cap executives about recent AGM presentations. With us today, I'm ecstatic to have for the first time Peter Pascali. He's President and CEO of Pyrogenesis Canada. The company trades on the TSX Venture Exchange under the stock symbol PYR. For our friends in the US, on the OTCQB under PYRNF. You can find them on the web at pyrogenesis.com or, of course, on Agoracom. Punch in their name, the stock symbol, get everything you need, including engaged discussions with the management company. Now, for those of you who are new to the story, Pyrogenesis is a world leader in the design, development, manufacture, and commercialization of plasma processes. That sounds like a mouthful, so don't worry about that. We're going to talk about that more with Peter in a minute. What you have to know is this. The technology is already in use on U.S. aircraft carriers to vaporize waste, as well as successfully tested by DARPA to destroy chemical weapons. And that's the agency of the Department of Defense that's responsible for the development of emerging technologies for the U.S. military. In addition to that, its titanium powders for advanced 3D printing have already received orders and interest from some of the world's biggest companies. As you can imagine, it's hard enough and probably a monumental feat to commercialize just one technology at any of these scales. Imagine multiple technologies. So it's no exaggeration when I say that Peter Pascali is Canada's emerging Elon Musk. Peter, welcome to the show.
Thanks very much, George. Glad to be here. I want to thank you very much for having me here. Agoracom is a great platform. We're really excited about it, particularly this new product. Our AGM has gone very, very well. I'm looking at this opportunity to introduce what we present at the AGM to your audience and to those who couldn't avail themselves of the time to be at the AGM themselves.
Yeah, and I think that's incredibly valuable because you didn't run just an average AGM where people read through the readings and the financial statements and go away. You've got so much going on that your presentation, I'm sure, was well received by the people who were able to attend.
George, very well received. The vibe was really good. We had the highest turnout ever, somewhere between 35 and 15 attendees, which in this day and age is quite good. We never had that many people. Very interested. They want to hear the story. The company's running all 5 cylinders right now. It's a very, very exciting time for Pyrogenesis. We've been at this for 20 plus years, and it seems to all be coming together all at the same time. Our additive manufacturing, our military, our mining metallurgy, a very exciting time, and I hope to be able to present that to your audience as well today.
And you're the 20-year overnight success story.
Well, it's taken some time. There's been ups and downs, and we survived them all. We've got a core group of 25 people who've been here we have 55 people in the company. We have 5 that's been over 20 years. However, half the company's over 10 years with the company. So in this day and age, that's also a feat. So the core group has been together for some time, and we managed to bring these different technologies to commercialization. We're all very happy.
Yeah, for the benefit of everyone at home, I'm going to throw my anecdotal evidence, and then we're going to go to the presentation. But Pyrogenesis is not your daddy's small cap company. This is a company that's achieving commercialization on multiple fronts. Significant facilities in Quebec from which they produce and manufacture and develop things. Tier 1 customers on all levels. So with that in mind, pay particular attention. This is the kind of company that we actually live for at Agoracom. I mean, they're all great, but when they get to this level, it's not an exaggeration. Again, it's not hyperbole when I say Pyrogenesis is in the top 1 percentile of small cap companies across North America.
What's really interesting about the Pyrogenesis, George, you touched upon it. It's a multi-legged stool. It's not just a one-trick pony.
Right.
And each one of those legs are turning into something quite incredible.
So with that in mind, pardon everyone at home, I got to do a screen share here so I can bring up your presentation. And that should show up on the screen in just a minute. And Peter, I'm going to hand over remote control to you.
Very good.
And you should have that. And for everyone at home, sit back and enjoy. Peter, take us through this, and I'll interject with questions naturally that I think will probably pop in the heads of people as they're watching at home as well.
Please do, George. And as I said, this was the presentation that was presented at our annual shareholders meeting a few weeks ago.
Last week, yeah.
Last week. And so, George, forward-looking statement. Just like to spend a few moments for people to take this in, and and actually, if they don't have the time to maybe later on at the end when they look it up on your platform, take a few minutes to look at the what's said in there. Basically, George, what we do is we commercialize. We're the world leader in the design, development, fabrication, as you said, and commercialization of something, plasma solutions. But one of the questions for somebody who's not familiar with us is, what is plasma? It's actually the fourth state of matter, and I don't want to sound too Star Trek-ish, but your science school teacher may have spoken to you about 3 states of matter. The examples given were the solid, liquid, and gas. An ice cube being a solid, if you heat it up, it becomes the next stage, a liquid or water. You heat up water or a liquid, and it becomes a gas. If you heat up a gas, it becomes a plasma. So plasma is basically a superheated gas. The sun is a plasma ball, lightning is a plasma. In fact, plasma is the most abundant form of matter. Probably over 95% of the universe is plasma. What we like about plasma, George, is its transformative properties. It can transform things from waste to energy, or wire to powders, like we use it in 3D printing. We take plasma and we put in our processes to do these type of things. And we have over 20 years of experience. We have over 250 years of combined expertise under here in Pyrogenesis. We argue to have one of the largest concentrations of plasma expertise under one roof. We have close to 60 patents worldwide, either issued or pending. And we're guided by a very experienced board. I'm the only director from the company. Everybody else is an outside director. I'll just quickly point out Alan Curley, the chairman of the board. He's the former Canadian chairman of the Canadian Commercial Corporation. And he also teaches corporate governance at the School of Directors in Ontario. Bob Radin is not your usual, he's a retired U.S. Army general, but he didn't deploy troops. What he did was he was involved in a lot of multi-billion-dollar contracts. So he helps us with that aspect of our military relationships. And Chris is helps us in our mining and metallurgy commercial products, having sat on the board of Hatch and has extensive experience in that industry. And Angel lends his experience with respect to reporting and financial accounting for public companies.
And I'm just going to interject there for everyone at home. This is critical when you have a board that's comprised of independent outside people. These aren't employees of the company that can be influenced by Peter and cajoled, which is quite often what happens in most small emerging companies when they're at the small stage. You just kind of put a board together of your key officers and employees. These are all independent. This is an independent board, which means on behalf of the shareholders, this is a board that's very strong in its oversight and fulfilling its role in supervising management, which includes Peter and his team. So Peter, I just wanted to show that. I don't think a lot of people know that, but that's a big strength of Pyrogenesis.
Well, it is, and what I do is I discourage. Actually, George, it's kind of funny. People ask me how many shares do my board members own, and it's a very, 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 very small, very, very, very small amount. I discourage them from owning shares because I want them to be entirely independent from the company and making their decisions, and that's also I think something very significant. They're extremely independent outside board members. This is, George, this is just the 2 slides of our facility. It's a 3,800 square meter facility in Montreal. Gives some people who cannot visit our facilities some sort of a sense of what they look like.
And that's about 40,000, just under 40,000 square feet, or right around there. So you talk about, that's a 1 acre facility. That's not a small, that isn't something small.
No, it's very big. It's very big. It's something that we can grow into to some extent. But for additive manufacturing, we're looking at actually moving into a new facility just to support that. So basically what I like to do, George, is describe our business lines in the context of our core traditional lines and additive manufacturing. Our core traditional lines have to do with the military, mining, and metallurgy. And just as a side note, additive manufacturing is we're leveraging off of something that we invented, something called plasmonization, which is we'll get into in a minute. With respect to our core and traditional lines, something very interesting with respect to Q1 highlights was we were cash flow positive from an EBITDA adjusted basis. So this is the second time we've done that in the past 3 quarters. Our revenue is up 67% Q1 2017 over Q1 2016. Our Our gross margin is a healthy 52%. Cash on hand, $1.3 million. Backlog of signed contracts, George, were $9.4 million. And taking the context of our historic revenues of somewhere between $5 and $6 million, I think that's rather remarkable. What I wanted to do in this presentation was highlight some of the pipeline that we've described in our various press releases, to put them in one place so that people can appreciate, okay, we're cash flow positive, EBITDA adjusted basis, we've got a healthy backlog, and give them a sense of the pipeline we've been describing in our press releases. And then once that's done, I will move on to additive manufacturing, which is extremely exciting. Having said that, what's key to know that our core traditional business line that I described as cash flow positive from an EBITDA adjusted basis has all the expenses associated with getting additive manufacturing up and running. So that's key.
You're killing two birds with one stone there, because
that's right.
All the expenses that are used for the core line are, it sounds like you're telling me, are most if not all the expenses used to create the 3D printing side. I know you call it additive manufacturing for people. So that's fantastic, because you're not having to, you don't have to double up expenses. You're already
that's right. That's right. The 3D printing, what the expenses there were, buying the machine, putting it together, hiring the people. They're all under the expenses under our core traditional line for this purpose. Okay, for this purpose only. So moving right along, I'd like to talk to you about our military line. The U.S. military and environmental was where we started off. Many years ago, the U.S. military had U.S. Navy in particular had a need to find ways to destroy waste on board the aircraft carrier. Congress had mandated they don't throw it overboard. And to make a long story short, they were confronted with large incinerators going through 3 decks of aircraft carrying weighing 100 tons. That was unpalatable. You can imagine this is probably the highest, most expensive real estate in the world. Every space, every pound is called for. And quite frankly, George, they didn't want to have, their goal is to put bombs and planes on this thing, not a big garbage can. So what they wanted to do is look at different ways that, different processes or technologies that could make this smaller and lighter. And to make a long story short, after about $50 million of investment, we ended up being the technology of choice, and we're actually in the design of the new aircraft carrier. The design was established a couple of years ago, and probably won't change for no one knows. Nobody knows how many aircraft carriers they make. But when they order an aircraft carrier, they're going to call us up and ask us for one of our systems. Go for in here about $5 to $7 million. That's highlighted in green. And the reason why I highlight this thing in green is because if you read the press, there's an anticipation that another aircraft carrier is going to be ordered this year. If that's the case.
And my interjection there is just the fact that Pyrogenesis system is specified in the design of future aircraft carriers. I'm not sure if everyone at home can understand the magnitude of that, but this is, one of the most important, not only the most expensive real estate in the world, but one of the most important assets that the U.S. Department of Defense has in order to defend its country and defend the world. And for Pyrogenesis to be specified in the design of future aircraft carriers, I can't imagine the multiple levels of security clearance, the kind of due diligence they had to do on you, the testing they had to do on you to make sure that you don't pose, the Pyrogenesis technology doesn't pose any kind of a threat or danger. So that, to me, the reason I'm saying this, third-party credibility. It's one thing for Peter and his team to be talking about how great their technology is, but when somebody like this does this, then it's rock solid.
You're right, George. I have to underscore something. We're not just in the design. We actually delivered 2 systems already. We actually delivered 2 systems to them. If one comes this year, it's going to be a 3rd system. And yes, George, it's the highest tech platform in the world. They have at their fingertips any technology they want. They chose us, and it has to do, George, not necessarily with all the clearances and whatnot, but the credibility that we will do what we say we're going to do, that the system will not fail, that it's entirely reliable. You can understand these aircraft carriers are mission critical, and they have to operate. You can't have garbage piling up and You can't have failures. They're not near necessarily, they're not near friendly ports all the time. So this speaks, George, to our credibility, to what this company has done. But you wouldn't build a company or a business around an aircraft carrier order every 2 or 3 years.
Right, absolutely.
But what it does, what it does do, it gives us significant credibility, not only within the military, but also outside of the military. And how it has its impact within the military, and there's an example here on the right-hand side of the screen. It speaks to what the project you referred to before with DARPA and special operations groups. Effectively, we were engaged by the US-UK Special Operations Group to destroy chemical warfare weapons like in Syria. So the idea would be they'd come upon or they know of some chemical warfare weapons. There'd be an operation put in place to destroy them. They'd send in our system, they destroy the chemical warfare weapons, and depending on the situation, they may destroy our system as well and get out. The key was to destroy the simulants with a 99.99% efficiency. And what we did was we demonstrated recently that we could destroy it to 6 nines, which was totally unheard of. Right now, the system is.
And by the way, and you have to destroy it in a way that doesn't, you can't just blast this stuff to smithereens and risk that it goes into the atmosphere, the environment. So you have to be able to not only do 6 nines, but be able to do it in such a way that it just literally vaporizes without any residual potential risk to anybody. Otherwise, what's the point?
That's right.
You do the job the terrorists for, but you can't do that.
To the specifications of the Special Operations Group, you're right. And right now it's being tested at their site for something in the order of $100 million, we've been told. The reason it's that expensive, George, is because to make these real chemical warfare reagents and test them and handle them, it's very, very expensive. That's not coming to us. I don't want to confuse anyone. That $100 million is a cost to them. But one would infer that if you're going to spend that type of money, that you might, there might be some sort of a purchase later on or further development. They will not tell us. They won't tell us what that is. They won't even tell us whether they're going to order or not. What we do know that each system is about $6 million fully militarized. It's going to be about $6 million a system. There are other applications. For instance, we will have a certification that our system has processed real chemical warfare reagents. Multi-billion-dollar companies don't have that type of access to testing. It's very rare that a company system will be tested with real chemical warfare reagents. But you can understand in this particular situation how we're being deployed. You'd want to know beforehand how it operates. But George, interesting sideline. This system can, if successful, can also destroy Ebola. And in countries like Liberia, there's a huge concern. There's a lot of Ebola contaminants, rags, blood samples that are transported from different sites to a central area to be destroyed. Well, the problem is, as it's being transported, they're targets for insurgents who'd love to get hold of Ebola and vectorize it. So the potential for our systems to go and destroy Ebola in a transportable with a transportable system. So we get rid of these convoys. That's a very exciting sideline we don't get into, but I'm just trying to explain to you a little bit about how these programs or these opportunities can evolve into something much bigger and much broader.
And suffice it to say, when you're out there trying to commercialize your plasma technology and processes and other applications, when you're coming to George Co., a big multinational corporation to pitch me on your latest plasma process for my business, knowing full well that you're able to pass and deliver on the Department of Defense, on DARPA, must be pretty much a business closer for you at the end of the day. Well, I don't have to worry about your ability to deliver this kind of technology.
Well, George, the hardest thing when you're knocking on a door is credibility. And that speaks a lot to credibility, because the nature of the beast in the military is you have to be able to do what you say you're going to do. The nature of the beast is deliver, equipment, food, bombs, what have you, at a certain time. And if you can't do that, if you can't do what you're going to say you're going to do, you're yesterday's news. And we've had a long-standing relationship with the military, the Navy, and that's because fundamentally that's how we operate. We do what we say we're going to do. We do it in the time frame that we say, and we're very proud and so should any investor, so should any Canadian be very proud of the relationship Pyrogenesis developed with U.S. military and maintained over the many years.
All right, so let's move on to other applications things. Shows more. I got more now.
So on the business line, if you look at the green on the side, I mentioned the 5 to 7 per system, the 6 million on DARPA. We've spoken about this in our press releases. This I speak to as our pipeline. I like to move over now to mining and metallurgy and describe 2 of the many things we're doing there. So we don't have time to talk about them all, but DROSRite is a very interesting process. It's essentially a process that recovers metal from dross, which is the waste generated in the metallurgical industry, the aluminum, zinc, copper. And effectively, dross is formed when in an aluminum smelter, when the aluminum it comes in contact with oxygen. And you have here some pictures of dross being formed. They're the big rocks on the bottom left being formed. And dross is a waste. So oxygen came in contact with the alumina. A dross is formed, and how they get rid of it, they scoop it up in a big, something like a spoon. They put it to the side. It cools down. And what they do is they transport it off-site to a third party who usually uses salt to recover the aluminum from it. And the reason why it's off-site is you don't want aluminum come in contact with, salt come in contact with aluminum because it'll contaminate the whole batch. So it has to be off-site. So it's transported to the third party. They heat it up. They recover the aluminum. It cools down, transported back, warmed up, and thrown back in the system. So there's a lot of, George, transportation, heating up, cooling down, a lot of costs. So what we did was we developed a system called DROSRite. It's an example of it's here on the left-hand side. And effectively what it is, it doesn't use salt. So George, we can put it right up against the smelter. We take the dross hot, we process it hot, we recover the aluminum hot, we turn it back hot, and we can do it for under $100 a ton. Conventional methods are about $250 to $350 a ton. Plus, we're getting significantly higher metal recovery, something in the order of 10 to 20%, which in this industry is unheard of. So where we are right now, they're about $1.6 million a system. Looking just, and I'll show you a slide in a moment, but the existing client, we're right now, as we speak, with our client, our first client in Mexico. It's a subsidiary of an American company that had a dross problem. They agreed to have a demonstration. They liked the demonstration. They ordered a conventional system. They have a need for another 3. We're currently we're now down there training them on the first one, and so that was, and interesting here, George, is there's a lot of people that wanted to be the first to be second, but it was very hard to get somebody to test it out.
Always first guy's impossible to get. 2, 3, 4, and 5, and 100 are easy.
As I said, there's a lot of people that want to be second. As soon as we came with this news, there's a group out of the Middle East that also wanted a demonstration. And when we're demonstrating it to them in the Middle East, they found out it was working without salt. They didn't believe. They came down. All management came down, took a look at it, and they have a need for about the equivalent of 4 of these type of systems. And as I mentioned in our press releases, we're discussing those as we speak. They've come off the religious holiday season now. We're back in discussions. We're going to summer. So there may be a delay of sorts, but this is very interesting. 4 systems, 7 systems, and all $11.2 million. We press release that is effectively in our pipeline for DROSRite alone. But when you look at the DROSRite potential, there's different aluminum dross, copper dross, zinc dross, and each one has primary, secondary, and tertiary producers. Our existing client, the one we have down in Mexico, is a casting producer, a tertiary, and we're going to target those, and we're trying cookie cutter them. But we're also targeting right now primary smelters. So just primary smelters alone in aluminum is about $280 million potential business for us. And this is a very exciting business line. It's a cookie cutter, so to speak. We're trying to figure out a recurring revenue stream, but right off the bat, it looks very promising, George.
Yeah, and you haven't even started to touch on copper and zinc. That's tremendous. I don't want to talk about those numbers. That's unbelievable. If you start extrapolating, the numbers get boggling. And I got to say, to interject here, that what I love about your dross technology and all your technology is you're not just going into an existing marketplace and shaving a couple of points and competing on price. You're creating a completely new paradigm where there's no competition because you're leaving the old guys in the dust. Essentially, you're Spotify versus people who were downloading music before at the end of the day. So That's what I really love about this.
It's a good comparison.
I love. That's why I love everything what you guys are doing. You're creating your own market at the end of the day.
So with respect to the overview slide, I've mentioned that there's 7 systems and for Drawstride in the pipeline, about $11.2 million. And I like to round off the core traditional business line pipeline with a review of something called PureVap and our relationship with HPQ, which many of the viewers will probably are familiar with. I believe they're on your site as well.
Right. They got to disclose that HPQ is a client of Agoracom as well.
That's right. That's right. So basically, from a 30,000-foot level, we've got a contract with a company called HPQ, Silicon Resources, to develop a process to convert high-grade quartz to solar-grade silicon metal in essentially one step. And why we like it is also because of the 10% royalty we'll get on all future revenues from them if they're successful. Conventional technology down at the bottom, conventional technology for a 20,000 metric ton system. Capital cost is about $665 million. And you end up with an end product of about $17 a kilogram. If we're successful, and we can do it in one step, the capital costs for that type of a capacity will be significantly reduced to about $50 million, but the spot price will decrease significantly to almost just above 10% of the current spot price.
So you're reducing capital costs by 90%.
Yeah,
that's just a blow away, because capital costs is where most companies fail at the end of the day. They have something great going on and they say, now all we need is $1 billion to build it, and good luck trying to find that money. Whereas here, $50 million, let's face it, you can finance that with pretty much anybody on the planet at this stage.
So George, the idea here, the goal is, and the original goal and the current goal is to convert high-grade quartz into high-grade silicon metal that could be used in solar panels. And if that's successful, it would enable the solar panel industry to skyrocket, because the cost of this metal is an impediment to their growth. Now, let's talk a bit about what does this mean. And I've been cautioned not to talk about Teminco, the Teminco process, because a lot of people lost money in that process. But George, there's a valuable lesson here that cannot go unnoticed. Right. What we're supposed to be able to do, what we're trying to do is take the PureVap process is take a quartz and with our vacuum arc furnace convert it to solar grade silicon in one step. Right. The conventional method is in the middle piece, where you basically go through a number of processes, electric arc furnace, then you hit it with some hydrochloric acid. There's a refining process, and you get solar grade silicon, and that's the conventional method. Well, back in around 2010, 2012, Teminco thought they came upon a process not to go do it in one step, but to reduce the number of steps. And when the market thought that they were onto something, their stock went from 30 cents a share to something in the low 20s dollars.
Actually, and their market cap, I remember back then it peaked at about $35 a share.
Was it that high?
Yeah, yeah.
Well, their market cap went to, it was in the billions. And I'm not suggesting that's where we're going to go. Absolutely not. What I'm trying to suggest that there's a serious commercial application and need if we're successful. Now, where are we at this stage? We're very, very excited about where we are. One of the things that we've spoken about, but we don't highlight too much, is the fact that in testing our process, and this is a bench test, we're going to make a prototype. We're in the process of constructing a prototype. But in the bench test, what we did was we decided to test our system. We wanted to know, how does the system handle impurities? So what would you do? Well, instead of starting with something of high purity, you start with a low purity quartz. And in doing so, we found that we could make, the end product was 3N, 99.9% pure metal. And it's not quite solar panel grade, but there's a huge industry that uses 3N purity. And I would make an argument that the fact that we can take low purity quartz and make it into 3N product, economic ramifications of that probably outweigh the original goal. Just as an
Really?
aside. So
That's
I
a
don't
big-
want to
that's a big
confuse people,
statement.
George. I don't want to confuse people and say they know we've changed. Absolutely not. We have a goal of going to solar grade metal, and we're very confident we'll get there. However, it's nice to have that safety net when you're looking at a business line. So it's very interesting. We're very excited about it. And as a summary, when you look at what we're doing in the military and you look at what's happening in mining and metallurgy, we've got in green about 5 in the military plus 6, 11 plus another 11, $22 million of pipeline, very high probability pipeline. And you put it on top of the fact that we've got a backlog of $9.4 million, which is about 50% more than historic revenues. You can see that our core traditional business lines are turning the corner and becoming cash flow positive and formidable in their own right.
And that's impressive on its own. If you ended the presentation right there, I'd tell everyone at home, Pyro has to be on your radar. I can't tell you to go buy the stock, but it's got to be on your radar.
No.
Now we're going to get to that, but wait, there's more moment, because what you're doing on the 3D printing side already has impressed me, and I want to hear more as you go through that right now.
Sure, I'll do that right now, George. What's key to understand within the additive manufacturing 3D printing is powders are critical to the printers. And we invented a process called plasma atomization. We're the inventors. We coined the name. It's now a household name in the industry. It's a way that you can convert a wire and make it into small spherical powders that flow like water. And that's what you'd want in your printers, correct? And there's a lot of consolidation going on in the marketplace. And we decided to re-enter the market and start producing powders. Now, somebody may ask, how did you get involved in this? Well, many years ago, we were involved in a program to develop lightweight armor for NATO. And we needed some titanium powders of a particular size, and it wasn't available. And if it was available, it was very, very expensive. So we decided to make our own. And we do it using a process. The examples are right here. And there's this tower on the left-hand side. And what we do is we have a wire in the middle. We have 3 torches. We have a wire descent in the middle of these 3 torches, and that's at the very top of the tower. And at the bottom, we collect very small spherical towers like the ones that are depicted here on the right-hand side. And we were making these powders for ourselves, not realizing this was before 3D printing, not realizing the biomedical industry really liked them. So we started selling them to the biomedical industry. But when we were done with our program with NATO, the biomedical industry wouldn't pick up all of our powders, so we got out of that business. And I'll touch upon that in a second. But when we're talking about powder and we're talking about 3D printing, a valid question is how big is that business? What are we talking about? Well, Wohlers, who's experts in the industry, to come out with an annual report, and they estimate that by 2020, there'll be over 14,000 printers requiring over 6.6 million kilograms of powder. And the
or over 8.6 kilograms.
What did I say? Sorry, I may have misspoke. 8.6 million kilograms of titanium of powder, metal powder, of which about 30% of it's titanium, which is exactly what we make. And it's interesting that that purple graph there is a graph of the size distribution. And what we make is exactly what 3D metal printers are using. 90% of 3D metal printers use one of these 2 fractions, 50 to 45 or 45 to 106. So when we got out of the business, we gave the rights to a company called, here's a picture of our powders. For those who are in the business, they'll look at them and find them extremely attractive. We got out of the business, and to make a long story short, AP&C ended up with the rights to our old technology, and they went into creditor protection, or their predecessor company did. And when they came out of creditor protection basically around the same time that 3D printing went from plastic to titanium, and they needed exactly the powders that we produced with our old technology. And AP&C coming out of creditor protection, one of their clients was Arcam. Arcam makes printers, and in short order, Arcam acquires AP&C for 35 million Canadian dollars in 2013. what's real interesting, George, is that under RCAM, APNC became the dominant supplier of titanium powder to 3D printers. Move fast forward to last year, GE acquires RCAM for $700 million and also Concept Laser for 600. Yeah.
So your technology was instrumental in this process between 2013 and 2016.
Well, you think so. I mean, I like to think that. When you look at the powder sizes, right under the names Concept Laser, they use 15 to 45. RCAM uses 45 to 106, which is exactly this particle size distribution that most of our technology, old technology makes. So what's also interesting is before Concept Laser was acquired by GE, they tried to acquire a company called SLM, and they refused, saying the bid was too low, but they made also 15 to 45. So when GE went to look for someone else, they went to look for that particle size, exact particle size, which was complementary to the RCAM one. I believe, I can't prove it, but I believe the powders that APNC makes were fundamental in their decision as to who they'd acquire.
So you're talking about $1.3 billion in acquisitions in 2016 by GE, premised primarily, or at least to a large extent, we don't know, on the quality of the 3D printing powder at the end of the day.
That's right. Well,
so now, devil's advocate, I would say, well, game's over, Peter, because if GE's made these acquisitions and they got this big name around the world, how are you going to compete with them? But there's dynamic that's been created now that's going to open the door for you.
Well, it's very interesting because this time was about 12, 15 months ago, I decided, we're going to get back, before this acquisition, we're going to get back into making powders. There's a huge business there. And we're the inventors. And in fact, we can actually improve upon the old process. We can do a number of things. Very, very exciting. We're going to get back in. And nobody really understood what I was getting at until GE made this acquisition. And all the focus was on powder producers. Because when we decided to get back in, George, we didn't want to take over the industry. We didn't want to take on APNC. We just wanted to be a credible second supplier to those that were buying off of APNC. Good business dictates that you want a second supplier. So we were just targeting like 5-6% of the marketplace. Nothing big. But along comes GE and makes this acquisition and fundamentally disrupts the supply chain, because between me and you, George, GE's doing this. I mean, Rolls-Royce, Siemens, Pratt & Whitney, all the end users are in similar programs. There's other printers out there that need powder. There's been fundamentally a disruption in the supply chain when APNC became a captive subsidiary of GE.
Because the customers are now also competitors of GE. So
exactly,
they don't want. I mean, they probably have to for now, but they don't want to keep feeding GE, their competitor, and A, making them rich, and B, probably holding them over some kind of strategic barrel at the same time. So now they really, really, really need a second source.
My thoughts exactly. And when you look at powder companies, powder producing companies, there are hardly any. There may be, the only other player that makes powder using plasma atomization is APNC and ourselves, nobody else. There may be a third company out there that we know of, but even if there was 20, there wouldn't be enough companies to service the demand that's being created by additive manufacturing. And George, just to go back sorry, our system is extremely flexible as well. Extremely flexible. In the center picture here, remember I told you we have a wire that descends through the middle here and you make powders? Well, we can change out the wire and make other powders. In fact, we did that recently with Inconel. We had a sample order for Inconel. We've never done it before. And when people ask me how long would it take to change out the wire, I had no clue, and I'd say maybe a couple of months, 3 months, 6 months. It took us less than a week, and we made some of the best Inconel powder that we could imagine, and we closed that contract. It was a sample order for Inconel and titanium. So it's very, very flexible, and we have a lot of ideas still on how we can actually enable 3D printing to go to different different levels and enter different markets by adjusting this system. I won't go into it here, but we're extremely, extremely excited about being in the market what GE has done, the excitement in the market, the lack of powder producers. In fact, recently, Carpenter bought a powder producer who made some very rough powders, but very specific to a particular 3D 3D printing. You see this purple diagram? It shows the particle size distribution.
Right.
Well, this company called Purist made rough ones up at the high end, where some other printers used. And Purist bought them. They were for sale. They were, I think, were having a rough time making ends meet, and they were bought for $35 million US. Just recently, in the past 6 months, past 6 or 7 months.
So clearly, there is a race on now. Can we call this? Can we say, Peter, that there is a race for titanium powders for 3D printers, and people are trying to position or acquire in order to position in order to position themselves? That's
what we're finding. As you noted before, we had some sample orders for. We're currently in our ramp up. So to continue the story, we're currently ramping up our system. We said we'd have it up and running by March 31st. First run, we did it. We're in a ramp up phase. And
did you expect to have 3 orders during your ramp up phase?
Absolutely not, George. And you can understand why. Our powders arguably may be very different at the end than they are now. So why would somebody order them? We in our business plan, we had the orders coming in subsequent to ramp up, which would be in the fall of this year. But we've had three orders from 3 different clients. One is a manufacturer of printers, one's an end user, and one's a distributor. Multi-billion-dollar companies spending money to qualify our powders. And I believe the question turns quickly to, can you supply us? Yes, we can. Usually the conversation or the attitude turns to, oh my goodness, how we can lock it up? How can we lock up the supply?
I was about to say that. Are you gonna get some kind of offtake deal where they say, okay, we need this many, was it kilos, tons? I'm not sure how it's sold, but let's say tons of this for the next 5 years. They want to lock that down.
That's right. That's right. I think George, the reason we got these sample orders so quickly is people in the industry know who we are, know what we've done as inventors, and are highly confident that the powders at the end of the day will be what they want. And they order the samples to start the qualification process and start entering into other types of discussions. And
this goes back to the DoD, DARPA, and everything else you've done. That's where the credibility comes in, whereas before, you might have had to go through ramp up and then testing and a long phase of testing and people trying to figure out if you have the ability. But all of that timeline, which I would say could easily be a 2-year process if you had just started these powders today as a standalone, nobody knew you. That's easily 2 to 3 years of trying to prove yourself. Here, you're not even at a ramp up yet, and you've got 3 orders from what you're saying are billion dollar companies.
That's right.
So that tells me on the balance of probabilities this is going to be. And then you wonder why I call you Canada's Elon Musk. But it's true. We say it's a joke, but I say, but I'm not joking when I say that, because
I appreciate
guys, that. I mean, Peter, I mean, you know this, but for everyone at home, people dream about, there are scientists and education faculties all over the world who dream about this happening just once on one product sometime during their lifetime. And you've got Peter and his team at Pyrogenesis doing it on multiple levels. That, to me, conceptually is just a blow away. So
and George, it's really the team that's here. It's an incredible team, and the relationships we have with universities here and around the world have been developed over time. And again, it's not something that you can actually go get into the marketplace. I mean, the credibility we have, we do what we say we're going to do. We're honest brokers. When there's a problem, we raise our hand and we're honest about it. And that has enabled us to develop the confidence in the marketplace that takes a lot of time to do that. But moving right along, these are press releases. These are press releases that on our additive manufacturing, which I've spoken to in some part in the course of this discussion.
Yeah, the timeline.
And effectively, again, we're very conservative, George. We very conservative. What we are doing for the first time is, given the interest in the marketplace, it usually takes between around 9 months to build one of these systems that makes powders. What we're doing is we're actually looking at pre-ordering equipment, or the equipment that we use, so that we have the ability to build 3 systems within 3 or 4 months. So we're going to pre-order some equipment without, that's what we're looking at doing. We're trying to do that. We think that's prudent right now. But basically, besides that, we're very conservative. What we're going to do is we've mentioned that we're going to spin off our additive manufacturing capabilities. We have a division, internal division called Pyrogenesis Additive. The idea here is to monetize, not only monetize the powder manufacturing business, but to make it easier for people to invest. We found there's a lot of money chasing additive manufacturing, but they don't want to get involved in military or DROSRite or PureVap. That's one thing. But if you're going to talk about joint ventures or even acquisitions or strategic alliances, they're going to want to know who they're doing it with. And so this is the reason why we decided to spin off these capabilities. Our strategic plan is to double powder production from cash flow. Very conservative. Very conservative. However, if a contract comes, we're going to speed that up. And also to adapt our process to other lucrative alloys, like I mentioned before. We do titanium, and we just tried Inconel. And right now, George, one of the key things we want to do is develop a strategic alliance relationship with a major player in the industry, be it within military, a 3D printer manufacturer, a distributor. I think that's something that would be key for us right now. The market
any decision you guys make, nobody can argue with. You've obviously been able to conceptualize and strategize and and plan these things out so well that I don't think there's anybody in the world that doubts you right now.
Well, thanks, George. I appreciate that. And this is a summary of the slide that I gave you before, with all the green being potential pipeline. What the green in the additive manufacturing, but I just want to be cautious. I'm not saying we're going to make 16 systems. And the reason why we got back in was, at the time we saw that if we used our old production rate, if we built 16 systems by 2020, and each one develops, assuming each one makes $12 million of revenue, we won't have tapped into more than 6% of the marketplace. And the idea is we don't have to corner the market. This is what I alluded to before. We just had to be a credible second supplier. So the market is beginning to understand what I've been talking about over the past couple of years, and it has been reflected in our stock price, where I went over this, our financials, and our stock price has increased nicely since December 31st. It's increased from about average volume of about 100,000 to over 450,000 now. Our stock price is trading between 75 and 85 cents. It's had some nice growth, and I believe this is in part by people actually understanding what our strategy has been over the past. Because fundamentally, nothing's changed from what I was saying a year ago. We're doing what we said we're going to do. And George, I think that's pretty much it. That's our closing prices and our volumes, and
I want to remind everyone at home, what other business started out and stayed alive and tried to take up the space of being a credible second supplier? That was Apple. A lot of people don't realize this, but back in the 90s, Apple was actually kept in business by Microsoft in order to avoid antitrust rules and antitrust potential conflicts. And they had, Apple stuck around as a credible second source supplier in the business, in the software and hardware industry. So if Apple's able to do what they're able to do, and you've already got a head start on the kind of on the powder, because your technology's already proven itself once and has led to some pretty big acquisitions over a 2-3 year period, and you're going back again, and you've already got orders from multi-billion-dollar companies. I'm very excited for that side of the business, because that's obviously that's potentially large-scale, global, recurring revenues, because 3D printing is off and running. It's never going back. So, Peter, normally at this stage I would say, what's next? Let's tell everyone at home what's next. But clearly we know what's next. It's just a case of execution at this point.
Exactly.
But give us your final words for everybody, because you got this chance to speak to your shareholders at home that weren't able to be there in Montreal.
Well, to our shareholders over the years, I'd like to thank you for your support and all the emails that I've gotten. And to those who haven't invested, watch us, get to understand what we're doing. And when the time is right, when you just choose to or not to, that's up to you. But it's a very exciting story. George, it's very difficult to get the vibe across here. We're running on all 5 cylinders. Everybody in the company is very excited, working long hours. We've just touched the tip of the iceberg when it comes to some of the things we're doing. DROSRite, PureVap, the DARPA project, additive manufacturing. In each one, we're just touching the tip of the iceberg. And again, what excites me about this company, it's a multi-legged stool. If something goes awry in additive manufacturing, we can hunker down on our core business, weather it, and move forward. Very exciting. Very happy where we are these days. And George, thank you very much for giving me the opportunity to talk to the investors who were not at the AGM and to have us on your platform. Really appreciate it.
Peter, thank you. Anytime an executive takes time out of their schedule, you've been on here for, looks like close to an hour. When you take that kind of time out of your busy day, you know, well, this is a big one because it's an AGM. Other presentation will be less time, but you had to because this is AGM presentation. But whenever someone takes this kind of time to communicate, that's always another one of those intangible great signs. Because I always say to myself, you know, who is this gentleman who's taking the time to talk in detail with that energy, with the positive vibe? Things got to be going well because you wouldn't be here, you know, on video that's going to be on YouTube and all sorts of other channels.
Well, George,
if you didn't feel that way.
For those that don't know, there's another spot on your platform where people can actually ask me a question, and I try to get to it as fast as I can, and I'll respond to it. I'll be the one responding to it as much as I can. It's within the public domain. Ask the questions. There's no question that's stupid. I will get back to you as fast as we can.
Yeah, and thanks for bringing that up, Peter. For everyone at home who's watching, especially current shareholders that are already invested, really want access. This has never been done before, but Pyrogenesis has a CEO verified discussion forum on the GoreCom. No profanity, no nonsense, none of the things that plague all the other. Go there, ask your question, get your answer. At the same time, read the questions and read the answers to other people. It's access that's never been given before, and most importantly, Peter, I think, is a transparency, that the question is posted for everyone to see, the answers posted for everyone to see, so you're treating all shareholders the same by giving everyone access. All you got to do is go to a GoreCom and read, and if you want to actually post questions, just create an account or use your Facebook or LinkedIn, and you can do the same thing. But
yeah, and nothing that's not public is disclosed there. It's all public information, but sometimes people need clarifications or elaborations, and that's what we're there for.
Yeah. I trust me. I was tempted to ask you, can you give us some kind of profile on the 3 powder companies that have already placed their orders? But obviously, I'm not going to because you can't answer. But you know, it's great to know that there are 3 large companies out there, and that's an example of a question you can't answer. But I'll try.
Not today.
You've been watching Peter Pascali. He's President CEO of Pyrogenesis Canada. The company trades on the TSX Venture Exchange under the stock symbol PYR. For our friends in the U.S., the company trades on the stock symbol PYRNF on the OTCQB. Find them on the web at pyrogenesis.com, and naturally get yourself over to GoreCom, punch in the company's name or stock symbol, get to the discussion forward, and away you go. So thanks for joining us, everyone at home. Have a great day. Peter, continued success. We can't wait to have you on next time.
Thanks, George. Anytime.